welcome back to Right Now Math with me, Mrs. Schmidt. Let me ask you, what does temperature, money profit or loss, and mountains and valleys all have in common? Well, they can all be expressed using positive and negative numbers. Today, we are going to learn about integers and their opposites. Let's get started. Let's remind ourselves. Positive numbers are greater than 0. They can be written with or without a positive sign. So some examples would be positive 1, positive 5, 20, and 10,000. So if a number does not have a positive symbol written in front of it or a plus sign, you can assume that the number is positive. Negative numbers are less than 0. They are written with a negative sign. So -1, -5, -20, and -10,000. In order for that number to be described as negative, you have to write that negative sign. Because remember, if it doesn't have one, we assume that it's a positive value. Positive and negative numbers. Positive numbers are always to the right of 0 on the number line, and they're considered a greater value than 0. Negative numbers are always to the left of 0 on the number line, and they are always considered less than 0. 0 is neither negative or positive. Opposites and integers. So this may be something new for you. So let's really take a look at, now that we've established what positive numbers are, what negative numbers are, what on earth are opposites? Well, opposites are two numbers that have the same distance from 0 on the number line, but on opposite sides of 0. They're called opposites. So the one thing I really want you to zero in on there is opposites are defined by distance from 0. In order to be considered an opposite value, the two numbers have to have the same distance from 0. So let's take a look at what we're talking about. Integers are the set of whole numbers and their opposites. So an integer are all whole numbers. Now remember, whole numbers are numbers that you would say when you count. So when you first started learning how to count, your parents taught you 1, 2, 3, 4, 5. And if you look, you can see this little arrow here. That means that if you continued counting on forever and ever and ever and ever and ever, that would include all the numbers, all the counting numbers. So counting numbers are not decimals and fractions. You would never say 1, 2, 3, 4, 4.5, 5, 6, 7, 8. So because 4.5 has a decimal portion, it's not a whole number. So what are integers? They are the set of all whole numbers and their opposites. So let's take a look. We have all of the whole number positive integers and their opposites. And what we just said here, opposites are two numbers but on different sides of the number line. They have the same distance from 0. So as you can see, 4 and -4 are considered opposites. And it's because they're both 4 units away from 0. 1, 2, 3, 4. Now over here, 1, 2, 3, 4. They're both 4 units away. It doesn't matter that -4 is to the left. You wouldn't say that it's -4 units away from 0. It's still only 4 hops away from 0. Distance is never negative. So that is why they're considered opposites, is because they are the same distance from 0. Something interesting about integers is that they can be used to describe real-life situations. So let's take a look at our chart. Here are our negative integers and here are our positive integers. So you can see that negative, temperatures below 0, below sea level, owing money, having a debt to your money, or taking a debt out of your bank account, basement car park levels, negative charged electricity, any loss or decrease, a withdrawal from your bank account, going down or west. Positive, temperatures above 0, above sea level, earning money, having money in the bank account, floors above the ground level, positively charged electricity, winds, gains or increases, deposits, up or east. All right, now let's practice writing positive and negative integers to describe situations. Our question says, write a positive negative integer to represent the situation. A contestant gains 250 points on a game show. So when you do this, you really want to zero in on those keywords that are going to indicate either a positive or a negative action. So if you are gaining points, that means you are increasing. So the integer would be positive 250, or you could just write 250 points. Let's take a look at another example. Gasoline freezes at 40 degrees below zero. So I've identified my quantity, and I've also identified a key word that's going to indicate either positive or negative. Below zero, we know that those values are negative quantities. So we are going to write negative 40 degrees. Integers can also be graphed on a number line. So let's take a look at what our question's asking us. Graphing integers and their opposites. So when given an integer, we want to plot that number and its opposite. Well, the first thing you're going to want to do is, if you have a blank number line, or if you have to draw a blank number line on your paper, is you're going to want to identify where zero is. So we know that zero will be about halfway on the number line. So I'm going to label to 6. 1, 2, 3, 4, 5, 6. And I'm going to label that 6. And the opposite of 6 would be the number on the other side of the number line that is the same number of spaces away from 0. So let's come over here and let's count back 6 spaces. -1, -2, -3, -4, -5, -6. Perfect. All right, so let's plot our next value. I'm going to put my 0, -4. So I know that my negative values are on the left-hand side of 0. So I'm going to count back 4 spaces. 1, 2, 3, 4. Label it. And my next question is, in the next part of the question, is asking me to graph its opposite. So 1, 2, 3, 4. And notice that opposites are always the same exact amount of spaces away from 0. 0 is almost like that line of symmetry. If you folded your number line right on 0, that 4 and -4 would lie on top of each other, or the 6 and -6 would lie on top of each other. So I'm going to treat plotting -12 a little bit differently. I can see that on the number line that I was given, I don't have enough interval marks to actually count by 1. So I'm going to count by 2's. -2, -4, -6, -8, -10, -12. So -12. Okay, the opposite of -12 would be on the other side of the number line, same number of spaces away. So 2, 4, 6, 8, 10, 12. And finally 1. So again, indicate where your 0 is. If 1 is right here, -1 would be on the other side of my 0, same amount of spaces away, just 1. That's it. So what did we learn today? Integers are the set of all whole numbers and their opposites. So if you look here, all the whole numbers, if you were just going to count forever and ever and ever, 1, 2, 3, 4, 5, all the way to infinity, that's what this arrow is including, all whole numbers and their opposites, the set of negative whole counting numbers, the set of all whole numbers and their opposites. 0 is neither negative or positive. How can integers be used? Well, we can use integers to describe real-life situations like temperature or elevation or gains or losses with money. And what else can we do? We can graph integers on the number line. So as we go back and look right here, we can see that we have 4 and its opposite 4 over there, and they are definitely the same distance away from 0. All right, everybody, I hope that was helpful, and I hope to see you again here at Right Now Math. Take it easy.